Hello there guys, and welcome back to another epic inexorable maths video. In this video we're looking at differentiating functions of the form f of x to the power of g of x. So this is really useful for when we want to differentiate things such as x to the power of x, or sine x to the power of e to the x, or let's do another one, tan x to the power of x cubed, or anything like this. We could do the natural log of x to the power of the natural log of x, or arcsine x to the power of x. Things like this. These are all functions of the form f of x to the power of g of x, aren't they? Because there is a function on the base and there is a function in the exponent. It's no longer, because we've already looked at when there is a number to the power of a function, so like a to the x or something like that. We've looked at that already. We've already looked at when there is a function, so x, let's say, to the power of a number, or sine x to the power of a number. We've seen this, but that would be the chain rule, for instance. But right here, we have this weird thing where it's like f of x to the power of g of x. So how do we deal with this? Well, the way that we do this is by using, once again, logarithmic differentiation. So logarithmic differentiation is one way that you can really easily prove the power rule for differentiation, which then leads to the quotient rule, etc. It's a really powerful concept, and that's what we're going to do to find the derivative of f of x to the g of x. And then what we'll do is we'll do an example. We'll differentiate x to the power of x to show you, because that one's quite nice to do. We'll do that. So this is how, if you wanted x to the x or something like that, you'd use this. So in general, f of x and g of x, this is how you do it. So you say that y is equal to your f of x to the power of g of x, okay? You do the logarithms, right? Take logs on both sides, natural logs. The natural log of y, and we're going to need implicit in a second, is equal to the natural log of f of x to the power of g of x, right? We're just taking natural logs on both sides. The natural log of one side is equal to the natural log of the other side. Beautiful. Then what we do is we can use logarithm rules. This is why logarithms do rule indeed, to bring the g of x down, and we get g of x multiplied by the natural log of f of x. Okay, so we just bring down the power from that logarithm. Amazing. There's no more situation now where something is in the power. There's no more powers. Amazing. So now we can just differentiate using the product rule and a cheeky bit of implicit differentiation. So let's implicitly differentiate both sides, because we have the natural log of y. We don't have y. So to use implicit differentiation, again, link in the description to the implicit differentiation video. But what we're going to do right now is we're going to differentiate the natural log of y with respect to x. So the way that we do this is we differentiate y with respect to y, or the natural log of y with respect to y. Gives us 1 over y, doesn't it? That's the derivative of the natural log of y. And then because of the chain rule, we multiply by the dy dx. That's the derivative with respect to x of the natural log of y. Then we differentiate the right-hand side, and we're going to use the product rule for this one. So let's keep the original g of x and then differentiate the natural log of f of x. So this is g of x times the derivative of the natural log of f of x, which is the derivative of f of x divided by f of x. That comes from the chain rule as well. This is the first term, and then we're going to add, and we're going to do it the other way around, right? We're going to differentiate g of x, so the derivative of g of x is g prime of x, and we're going to multiply by the original on the left-hand side, which is the natural log of f of x. Amazing. Brilliant. And then all we have to do now is make dy dx the subject. So we're going to multiply both sides by y. Dy dx is therefore equal to y times g of x times f prime of x over f of x plus y times g prime of x times the natural log of f of x, just like this, okay? So this is multiplying both sides by y. Now, we could say we're done, we're finished, we've got dy dx, but of course there is a y on the right-hand side. We don't want there to be a y on the right-hand side, so we're going to replace that y with what we already said y was. We remember the original point of the question is we've said that y is equal to f of x to the power of g of x. So we're going to replace all of the y's with f of x to the g of x's. So what we get is dy dx is equal to y, which is f of x to the power of g of x, times the g of x, times f prime of x over f of x, plus the next term, which is going to be y, which again we've already said is f of x to the power of g of x, times g prime of x times the natural log of f of x. Amazing. And from here, you can say that you are done. Now, there's some things that you can do if you want to make this look a bit different. You don't have to do this, but one thing that we can do is we can use index laws almost to say, well, we have right here, there's an f of x to the g of x, but we are dividing by f of x. So if you do want to simplify this ever so slightly, you can write this as f of x to the power of g of x minus 1 times g of x times f prime of x. That's the first term, right? We don't need to divide by f of x anymore because we took it off the power there. And then we can just write the second term in, and this doesn't simplify, so we get f of x, g of x, g prime of x, ln of f of x. Okay, and you can manipulate this, you can move it around if you really want to, but that's the gist of it. So the derivative, it's quite long, isn't it? Don't remember this. This is not like a rule that you should remember. This is just how you would do it, okay? It doesn't matter really what this says, but this is how you would do it. This would be the derivative, but it's quite disgusting, isn't it? So the derivative of f of x to the g of x is f of x to the g of x minus 1 times g of x times the derivative of f of x plus f of x to the power of g of x times the derivative of g of x times the natural log of f of x. It's ridiculous. It's absolutely crazy. Depending on what the function is, you should be able to simplify this a little bit more. So it's not going to be so bad when we actually use specific functions. So as an example of how you would actually use this in a real life situation, y equals x to the x. That's a nice one. What's the derivative of x to the power of x? Well, we're going to do the same thing. So we're going to take natural logs of both sides. We get the natural log of y is equal to the natural log of x to the power of x. Amazing. Then we're going to use logarithm rules to bring down that x from the power on the right hand side. And we get that the natural log of y is equal to x times the natural log of x. Then we're going to implicitly differentiate both sides using the exact same logic as earlier on in this video. The derivative of the natural log of y with respect to x is 1 over y dy dx. Then we're going to use the product rule here. So let's do x times the derivative of the natural log of x. This is x multiplied by 1 over x. We'll go and deal with that in a second. And then let's do the derivative of x times the original natural log of x, or the derivative of x is uno, it's just 1, and the natural log of x stays like that, natural log of x, amazing. And simplifying this just a little bit, we get 1 over y dy dx is equal to x over x. This is simply 1 plus the natural log of x. That does not change. Then, of course, we need to make dy dx the subject. So what we're going to do, we're going to multiply by y. So dy dx is equal to y times 1 plus the natural log of x. You can distribute that if you feel adventurous. And all we're going to do now is we're going to replace the y with the definition of y, which we already said it was. We said in this question, y is x to the power of x. So we're going to replace that with x to the power of x. And it's x to the power of x, 1 plus the natural log of x. This is the answer. If you want to, you can distribute the x to the x. You can get x to the x plus x to the x ln x. You're absolutely allowed to do that. It's absolutely fine. This is the derivative, however, of x to the power of x. This is how you would do it. You would use logarithmic differentiation, a really, really powerful and underrated differentiation strategy. So yeah, in general, that's how you differentiate functions of the form x to the x. If you enjoyed the video, thank you so much for watching. I highly appreciate it, and I'll see you in the next video. Cheers.